I want to welcome everybody to the Engage Truth YouTube channel and Engage Truth podcast. I'm your host, Caleb Harrelson, today. And I have a very special guest with me, Dr. Jason Lisle. I'm super excited to have him with me. I've been reading his books for a long time. He's a astrophysicist. He's worked with many creation ministries, and now he has the Biblical Science Institute and doing amazing work with that ministry and speaking around the country before the lockdown that is, and hopefully he'll be out after the lockdown is up. So we're so excited to have you with us today, Dr. Lisle. How are you doing?
I'm good. Thank you for having me on.
Yes, sir. Yes, sir. Well, we're excited to have you on here, and we have a lot of questions that we're going to be covering, and I'm excited to get into these questions today. We're going to be talking a lot about space, maybe some black holes, distant starlight, Big Bang, and all those topics that everybody wants to talk about, and for good reason, because for one, it's beautiful to look at in space, and it's God's creation. But I think a lot of people are trying to make sense of the things that we see and understand, and particularly what we hear from secular scientists and that story. But I think even before we get into that, I wanted you to talk about the importance of our starting place in knowledge itself. Where should we start? And when it comes to the knowledge of everything, ultimately, what's a good starting place? Like, how would you break that down?
Whenever we come into any kind of conclusion about what's true and what's false, we have certain standards by which we evaluate that. And we use things like laws of logic, and we use the methods of science to discover certain truth claims. So there are these various methods that we use, and there's disagreement about which method is the best, or in a given situation, which method is the best. So we all have a standard by which we evaluate the evidence. And the problem is, most people haven't given any thought to what their standard is. What is the standard by which we reason, by which we come to certain positions on what's true and what's not? And so what I try to do is encourage people to think through, what are you assuming? What is your foundational standard that you're assuming to be true? And I would suggest to everyone that the Bible should be our ultimate starting point. It should be the foundation through which we interpret the evidence around us. And the reasons for that are numerous, but the main one is the Bible is the Word of God. God knows everything. His mind determines what's true. His mind's different from ours. Our minds discover truth. God's mind determines truth. What he thinks is what is. He speaks and the universe leaps into existence. And so if we want to be truthful, if we want to have a good understanding of the universe, we need to start with what God has said about it. God is truthful. And so he's not going to lie to us. He's not the author of deception or confusion. And so when we read his word, we get a true understanding of the nature of the universe, the nature of man, the nature of reality. Even things like laws of logic, I would argue, have their basis actually in Scripture, because they're reflecting the way God thinks about things. And so basically the only alternative to starting with God's word is you start with a guess. I mean, that's really what it comes down to. You can either start with certain knowledge that's been given to us by God, or you can start with a guess. Those are your options. And I'd rather start with absolute truth. And granted, not all truth is in the Bible, but everything in the Bible's true. And so it provides kind of a foundation by which we can then learn other things about the universe.
Right, yeah, it's sufficient for what we need. It doesn't cover every topic. Yeah, thank you for that breakdown. I'll just jump into, I'm sure you've heard of this before, the Euthyphro dilemma. Is something true or good because God says it's good? Or is he, so is that kind of arbitrary? Or what's the other option out? Help me out here.
Yeah, is something good because it's something the gods approve of, or do the gods approve of something because it's good? And the Christian worldview resolves that. Something is good if it's something God approves of. And you say, was that arbitrary? No, because there's only one God. And he determines reality. And so therefore what he says is good is what's good. And some people, what if God said something is good that is clearly bad? Well, God wouldn't do that. You see, God is internally consistent. And so the Euthyphro paradox is a paradox in Greek thinking, where their gods are arbitrary and can change their mind and so on. And so, which God do you follow? If you're going to have a polytheistic religion, that's a problem, because which God do you follow in terms of if Zeus approves of something but Hera disapproves of it, is it good or is it not?
Right.
And so it is arbitrary in a Greek or polytheistic worldview. But in the
Mm.
Christian worldview, God is the source of absolute truth. His mind determines what's true, and so it's not a paradox in the Christian worldview. What is good is that which God approves of, that which He commends, that which incurs His blessings. What is bad is what God disapproves of, what incurs His wrath.
Yeah, absolutely. Thanks for breaking that down. So he's not looking up to a standard or arbitrarily. I've heard that it said that he is the standard in his nature, right?
Yeah, and that nature is unchanging.
Mm.
So we're going to have an object and is sovereign over the universe. So that's what makes
Right.
it different from the Greek gods that had their own localities where they would rule. No, God's sovereign over everything, and so what He approves of, that is universal and unchanging, because God is universal and unchanging.
Yeah, right. Absolutely. You know, I've heard it said through one of my friends. He said he would embrace the methodological naturalist worldview, and so he would say, well, we have no access to the supernatural and only the natural world. So, um, yet he's claiming that reasoning is possible. So I'm curious, how would you even respond to that? How
There,
could we reason if there is no supernatural? I'm sure you could break that down, but
yeah, I think that's a problem. Of course, there's metaphysical naturalism, which is the belief that there is no supernatural, that everything that occurs happens within nature. And then there's methodological naturalism, which is the belief that although there may be a supernatural, we should pretend there isn't when we're doing our science. And I find
hmm,
both of those utterly irrational. In particular, methodological naturalism, because that view acknowledges that there can be a supernatural, but we should basically pretend that there isn't when we're doing our science. We should act as if the universe is naturalistic. And I find that irrational. Why would you arbitrarily uh, act on a belief that you know might be wrong? And there are even Christians who embrace methodological naturalism when they approach science. And I'm thinking that makes no sense, because on the one hand, you do believe in God. On the other hand, you pretend He doesn't exist when you're doing science. And I think it comes from a misunderstanding of the nature of God and the way He interacts with the universe. Many people think that God set up the universe to work autonomously. It just kind of works on its own, and then maybe
hmm,
occasionally God will do a miracle. He'll intervene and do a miracle. That's not the Christian position. The Christian position is that God constantly upholds the universe by the word of His power. He's constantly intervening. It doesn't even make sense. He's upholding the universe. He's causing things to happen. He's in charge of history and the way things have turned out, and so on and so forth. And so so I would say we do have access to the supernatural in a couple of ways. First of all, the natural depends on the supernatural. The natural is controlled by God, who is beyond nature. And that's why we can do things like science, because we rely upon God upholding the universe in a consistent way, and so on. But I think the point you're probably pushing for is, can we have rationality in a
yeah,
natural
that too. Hmm.
universe? Yeah, and I don't think we can, because rationality involves consciousness. It involves conscious deliberation, where I can look at the various options and then choose the right one. And if my mind's just chemistry, there's no freedom of choice there, because chemistry can't choose anything. Chemistry doesn't, deliberate and make conscious choices, and there's no freedom of choice if we're just chemistry. And so the naturalistic worldview ironically undermines the rationality upon which some people think that it's based. It's not rational. It's fundamentally irrational, because it would undermine rationality. The Christian worldview can make sense of rationality, because I'm not just physical. I'm a body and a spirit. I have an immaterial aspect to me, and therefore I can think, because I'm made in the image of God, and so I have a certain freedom to consider the various options and choose the best. So my worldview can make sense of rationality. Naturalism can't.
Yeah, yeah, absolutely. So I guess on unpacking that even further, I've heard a methodological naturalist say that, well, we have descriptive and prescriptive laws in the universe. Um, and so by prescriptive, they're talking about, like, say, a speed limit, and then descriptive, like the laws of nature. And I think I've seen them say, well, um, to the argument that we need every law has a lawgiver in nature, and so they're saying, they would say, my understanding is that, well, these some laws, they just exist out of necessity. It doesn't need to have a lawgiver, talking about I guess the laws of nature. They were saying that's just describing what is. So we don't have to fill in God, or they would say the God of the gap. So we don't know out of ignorance, therefore God. That's my understanding of the case they're making. How would you respond to that? Like, does it exist out of necessity, the laws of nature?
No, the laws of nature don't, they need justification. You need to have some kind of basis for believing in them. And the fact is, scientists, although some may say that the laws of nature are merely descriptions of how the universe works, they don't treat them that way. Because we use laws of nature to predict future states of the
Hmm.
universe. And I've done this kind of stuff. We do this in astrophysics all the time. We can
Right.
we can take the laws of nature and predict in advance where the planets will be tomorrow or the day after that or 100 years from now. It's amazing we can do that because they're not. Now, see, if they were simply descriptions, you can't describe what's going to happen in the future because you haven't observed it. If they're simply descriptions of what we observed, they would only apply to the past, and they would only apply to the places where we've observed them. And so the fact is, physicists don't treat laws of nature as simply our systematized observations of what we've seen in the past and the places we've explored. They treat them as universal laws that will continue to apply in the future, laws that the universe has to obey. And so they're more than just descriptions. They are descriptions, there's no doubt about that, of the way
Sure.
the universe behaves, but they're more than that because they allow us to predict future states and they allow us to predict or describe what's going to happen in areas of the universe that we've never observed. And so then my question would be, how do you know that laws of nature work in the Andromeda Galaxy the same way they work on Earth? I mean, you haven't been to the Andromeda Galaxy to observe that. How do you know that? How do you know they'll work tomorrow the way they've worked today? And I would argue that the Christian has a basis for that. The Christian can say, well, because laws of nature are basically the way God upholds creation. And God's promised us certain uniformity in nature, that the basic seasons, day and night, and so on, will be in the futures. They've been in the past, Genesis 8:22. And God's sovereign over the entire universe. He's just as active in the Andromeda Galaxy, upholding it as he does the Earth. So we'd expect him to be the same there. Conditions will be different, but the laws, the way that God upholds creation is consistent because of his nature. And so I, as a Christian, can make sense of science and induction and things like that. And the secularists really can't.
Yeah, absolutely. Yeah, thanks for that explanation. So, one more on this, and then we'll get in more into the nitty gritty of other things related to astronomy and so forth. So I've heard a lot of people saying the scientific method. Well, that's our only form of knowledge. I hear a lot of particularly methodological naturalists saying that, and of course you hear that all over society. Is we don't need any other form of knowledge. We have empirical data, and that's all that is available to us. So what would you say to that?
Did that come through? Sorry about that. I don't know what
Oh,
that
it's
is.
good.
I just want to make sure my apartment's not on fire here. Um, yeah, yeah. People, a lot of times people will claim that, but
Right.
nobody can live by that standard. Nobody can live by
Mm,
that standard because the fact is there are many things that we hold to be true that are not determined scientifically. Laws of logic are not discovered by scientific analysis. Most mathematical truths are not discovered by scientific analysis. The fact that 2 million plus 3 million equals 5 million. Now, I doubt anyone has actually counted that to see if that's true scientifically, right? Because scientifically, you'd have to actually do that. You'd have to actually take 2
mm,
million things, add them to 3 million things, and then count the answer. That's not how we do it. We use other methods to determine mathematical truths, to discover them. Moral truths can't be determined by scientific observation because science only tells you, basically, science is designed to describe how the universe works now. And basically, it's describing the systematic way that God upholds creation and the way that he will continue to uphold creation, which is why we can use it to predict future outcomes. But it's not the limit of truth. Think about historical claims. Imagine you went into a laboratory and somebody's mixing some chemicals there, and you say, "Oh, what are you trying to discover?" And he says, "The date of the American Civil War." That would be ridiculous, right? I mean, you can't determine that by scientific means. You can't do that. That's not something you can test and repeat in a laboratory. If you want to learn about a historical claim, you go get a history book. You go to your library and you get some history books. And well, how can we know that they're accurate? Well, you can compare them with other history books, and there are ways of judging historical claims, but science
sure.
isn't one. And so there are lots of regions of truth that are not accessible to the scientific method.
Mm,
And I think we need to recognize that. People rightly respect science because it has given us some amazing things, but we need to recognize it's only one tool of several that God has given us by which we can test certain kinds of truth claims. And it works. Science works very well in the realm in which it's designed to work,
Right.
testing the systematic, repeatable way God upholds the universe today. You want to try to apply it to historical claims, doesn't work as well. That's not to say that there's no application at all, but it doesn't work as well because it's not designed to rediscover the past. It's designed to explain and describe and predict the way the universe behaves today.
Yeah, I really like that breakdown. You're saying, science, the scientific method of testable, observable, repeatable, is very useful, but there are other realms of knowledge that we can't apply the scientific method to. And I think it's really relevant for what we're going to talk about coming up here is that I've seen a lot of people discount even looking at, say, like even your work or many other very reputable scientists that are believers and that hold a particular view of the age of the Earth because I think they may be mixing up what's the approach when it comes to say a creation science perspective of what are we saying is scientific and what are we saying is a good inference, like because people say, for example, the age of the universe, can that be a scientific statement or is that more of an inference off of the data we see, and or is that more fall in the realm of this is primarily a statement from scripture and then that's our starting point? So maybe you can unravel some of what
Sure.
I unpacked there.
Yeah. Anytime you talk about the age of something, that generally is not accessible to scientific
Okay.
methods
Right.
because the scientific method involves observation, experimentation, repeatability. If you didn't observe the thing come into existence, you can't scientifically determine its age. Now, that's not to say you can't use the methods of science to make a guess about its age. You can. But ultimately, those will not be testable. You can't repeat that in a laboratory. If we had time machines, then the past would be accessible to science. We could go back in time and check. We could see if our observations, we could see if observations match our prediction, but you can't do that. So anytime you talk about the age of something, you're actually talking about a history question. And while science can help us fill in some gaps in history sometimes, it's not really designed to answer history questions. It's designed to discover the way the universe works today. The best way to answer a history question is with a history book. And
Yeah.
as it happens, we have a history book that records the origin of the Earth and the universe and so on. And it tells us it's not billions of years old. It's much more recent than that. I think the science confirms that. Maybe we'll get to that later.
Yeah.
The ultimate reason that we know that the Earth's not billions of years old is because we know from recorded history. The origin of the Earth is part of recorded history. And it's not just any history book. It's the history book written by inspiration of God. So it's going to be absolutely inerrant.
Yeah, absolutely. And I know I may have some listeners who are watching the live feed or will listen later, and they're immediately like, yeah, I don't know if I can listen further, but we're going to dive into that more. But I really like your breakdown of clarifying just the misunderstanding that I think people have of the actual claims that creation scientists are saying. I think you broke down really the difference between science and history and how we're coming to different conclusions, because that has to be a good starting point, that foundation laid down. So let's get to because the claim related to Genesis is history, God's word, and saying it starts in Genesis, the foundation for marriage, morality, foundation ultimately for the gospel is laid in Genesis. And as a Christian, I think that's so vital that we understand the importance of, we need to realize that our foundation is here, and we need to be able to explain it, defend it as is history, and why it's good history. So let's start with one of the biggest claims I hear, I hear where they say, well, Genesis from the get-go, it doesn't even match science because, and one of the things they'll say is a universe can come from nothing, and they're appealing to is what is called the quantum fluctuation. And I think that's an appeal to in my understanding, it's called the Heisenberg uncertainty principle. So maybe you can explain, first of all, what is a quantum fluctuation, Heisenberg uncertainty principle, and can a universe actually come from nothing? Because I've heard people say, well, the laws of logic work good in everyday life, but when it comes to quantum physics, they're essentially saying the laws of logic don't apply and that the universe can come from nothing. So,
A lot to unpack there.
yeah.
I think I'll start with the last first, the idea that laws of logic don't apply in the quantum realm. That's absurd.
Yeah.
If they didn't, we could never have discovered anything about the quantum realm because we use logic in science. We use logic to derive certain truth claims from other truth claims. And if quantum mechanics violated laws of logic, we wouldn't know anything about it because we don't have any other method of deductive reasoning other than laws of logic. So I think the reason people have that misconception is a particular view called the Copenhagen interpretation, and it has to do, if you've heard of the Schrodinger's cat experiment, and Schrodinger's cat experiment basically says if you have a cat in a box that you can't see inside the box, and inside there is a vial of poison that is released at a random time. There's a radioactive element there, and when it spits out a certain neutron, it activates the vial and kills the cat. But you don't know when it's going to happen. And so the Schrodinger's cat philosophy says that until you open the box, you can consider the cat both dead and alive. And and of course, nobody believes that really applies to things like cats. But in the subatomic world, in subatomic particles, they basically don't exist as a discrete particle with a location in space until they're observed, amazingly. While they're unobserved, they act like waves. And you can say, how do we know that then? How do we know that they act like waves when they're not observed? And the answer is through logical reasoning from when we do observe them. Their pattern, it's complicated, but their pattern indicates that they have acted like waves when we haven't been observing them. It's really strange. And so the idea that, well, the particle exists and it doesn't exist until you look at it, it's not really true. It does exist, and it exists as a wave. It exists as a wave until you make an observation, and then that wave function collapses, and the particle will assume a discrete position in space. So basically, think of a particle that's created. If you're not observing it, it will spread out like a wave. Like think of a ripple in the pond. That particle will act like a ripple in the pond. So it might be here, it might be there, it could be anywhere on the ripple. Okay, until you look at it, until you observe it, and then that will force it to be in one of the locations on the ripple. Now it's very strange that the universe works that way. We wouldn't have expected that, but that's the way it works. And there's nothing illogical about that because it's not that the particle is here and not here at the same time and in the same sense. It doesn't violate the law of non-contradiction nor any law of logic. So quantum mechanics, it's strange, but it's rational. And if it weren't, we couldn't have discovered it. We couldn't have learned anything about it. So the Heisenberg uncertainty principle actually comes from the wave nature of matter, and it basically puts a limit on the precision with which we can know something. And so it turns out that you can't know both the momentum, how fast a particle's moving, and its position simultaneously below a certain level of precision. And that's hard for us to imagine because in everyday life we don't observe that. If you want more precision, you get a better instrument. You get a better instrument, but there's a limit. And that's just due to the wave nature of matter, basically. One of the things that means is that you can have things called quantum fluctuations, where space-time will produce apparently what are called virtual particles that have a very fleeting existence. They have almost no energy. In fact, a net energy, I guess, of zero. But they exist for a very brief amount of time, and then they cease to exist. They go back into space-time. And some people think, well, see, there you go. You got something coming from nothing. But no, you don't. You have something coming from space-time. And people think of empty space as nothing, but it's not nothing. It's something because we can measure it. Empty space has volume, right, which means it has properties. It's three-dimensional. And then, of course, we have the dimension of time as well. So space-time is a four-dimensional manifold in which matter exists. So space-time is not nothing. It's something. It has properties. It can be stretched. Space can be stretched, and so on. It can have a sort of velocity to it, which is how black holes work, and so on. So space is not nothing. It's something. And space-time, has the ability to produce temporarily particles, which then almost immediately exist. And it's thought that this is how fundamental forces like the electromagnetic force are transmitted between particles. And there are parts of this that are pretty well established, other parts that are a little more theoretical, but that does seem to be a real phenomenon. So does something really come from nothing? No. And I would argue that that would violate causality, which I would put under a law of logic. Nothing comes from nothing.
Right.
Things only come from other things. And so could the universe itself have come into existence from a quantum fluctuation? No, because quantum fluctuations need a universe to produce them. And so, and that's why some physicists have even said, well, maybe there's another universe out there that produced this one. That's not going to work either, because by definition, one universe cannot affect another universe.
Yeah.
Otherwise, they wouldn't be two different universes. If they're connected, they're just two domains of one universe. So you cannot appeal to a quantum fluctuation logically as the origin of the universe. Of course, in the Christian worldview, we have a God who's always existed. There's nothing illogical about that, although it's hard for us to comprehend. And he has created the universe, and that violates no laws of logic. That's consistent.
Yeah, amen. I like how you broke down the common misunderstanding that people think that space is nothing, and it's not. And you also, right. And I think the last Avengers movie was built off of a quantum fluctuation. So you just refuted the whole premise of the movie.
Yeah, there's more than one way to do that.
Yeah, a lot of different angles. Yeah, you know, that's awesome. So you probably heard of the multiverse theory from a lot of secular scientists. So can you explain basically what that is?
Yeah, the idea is that there are multiple universes out there. There are many different universes, and ours is just one. And I think the main motivation behind that is a secular one. It's because we've noticed that our universe is very well suited for life to exist, for life to be possible. And that's true. There are certain constants in nature that have to be pretty close to what they are. The balance of the electromagnetic force to the other forces and so on. If you change those too much, well, some more than others. I mean, there's some leeway, but if you change them too much, then atoms can't exist, and so then you can't have beings like ourselves that are made of matter and so on. So our universe is designed for life, and that makes sense in a Christian worldview. In the secular worldview, it's like, well, how did we get so lucky? And I think one of the main answers to that is, well, perhaps there are essentially an infinite number of universes, and we just happen to be in the one that allows for life to be possible. That's not really a logical inference. That's, I think, a form of the gambler's fallacy. The idea that we just happen to live in the lucky one, that implies the existence of all these other unlucky ones. No, it really doesn't. It really doesn't. So scientifically, when people try to propose a multiverse, I mean, you can entertain that as a philosophical issue, but it's not a scientific one, because by definition, another universe cannot be known by us through scientific means. The only way we could know about another universe is if God told us He made another one. That's the only way we could know about it. Because if we know about it through our universe, then there would have to be some interaction between the two, in which case they wouldn't be different universes. They would be two sections of a single universe. So I find the multiverse theory inherently irrational.
Right. Yeah, absolutely agree. And that seems like a greater leap of blind faith, if you will, to me. Doesn't seem like it's reasoning off of good evidence there.
Yeah,
Now, I go ahead.
I don't think it is. I don't think it's based on good reason.
Right. Now, here's another interesting area is dark matter. What is that? Does it exist? Why does it matter to secular scientists, or does it matter?
Mm-hmm. Yeah, I think it does exist. Some people have the misconception that it's a secular rescuing device, and I can't blame them, because there are lots of secular rescuing devices out there that are designed to explain away things that are evidence for design and so on. No, dark matter was discovered decades ago by studying the motions of stars as they orbit in their galaxy. Believe it or not, we can measure that motion, or at least one aspect of it. The Doppler shift of the stars. You imagine a galaxy that's spiral, and they rotate, and the stars near the core, they complete a circuit in less time than stars near the perimeter. And we can measure, if the galaxy's tilted sort of toward our perspective, then we can measure the Doppler shift and measure the speeds of these stars. And then from Newton's laws, we can calculate the mass interior to that star. It turns out that if you have one object orbiting another, based on the period, you can determine the mass of the interior object. And it turns out masses exterior to that kind of cancel out if they're in a spherical distribution, so that you don't have to worry about those. And so you can actually compute what the mass of the galaxy is based on the motions of the stars. It's really quite incredible. And what they found was that galaxies are about 10 times more massive than can be explained by the combination of all the things we see in that galaxy, things like stars and gas and dust. You add up all that mass, and it's insufficient to explain why these stars are orbiting so fast. There must be more mass in a galaxy than what we see, and about 10 times more. So if dark matter is right, I think it's the best explanation. Then that means we're only seeing about what we see in the universe, and things like dust that we can see through other wavelengths, is only a small fraction of what's out there. It's only about 10% of what's out there. And what dark matter is, we don't know. It could be some undiscovered particles in physics that don't interact very much with ordinary matter, so that's why they're hard to detect. That's the leading theory. The only alternative to dark matter would be that the laws of physics are not what we think they are. That they're close. They have to be close because we can make good predictions about the positions of the planets and so on. But the idea is they could be a little bit off when accelerations are very, very weak. So there's what's called the MOND theory, modified Newtonian dynamics, and I think that's less likely, but it's possible. But I think dark matter is the more likely candidate. Not everything that exists is visible, and I think God might be using dark matter to teach us a lesson about that. I mean, you have physicists who believe, most physicists believe in dark, or astrophysicists believe in dark matter as a reasonable inference based on the things we do see, that there must be something that we don't see that's affecting it. And I think that has an enormous spiritual application.
Yeah. Is there any interesting research or that you'd recommend people who want to dive into that topic more as far as dark matter goes?
My colleague Danny Faulkner has written some
really?
articles on that. Danny Faulkner,
Awesome.
and he's over at the Answers in Genesis Ministry. So you can take a look at some of his art. He's done one just on dark matter that I think would be a great introduction to that. And he goes through some of the history of it as well, as to when these discoveries were made and why dark matter. And there's more than one line of evidence too that indicates that dark matter exists. It's not just the motion of stars, but the bending of light. An event called gravitational lensing. Believe it or not, gravity bends light. And we don't notice that very much on Earth because our gravity here is very weak, but you go out to distant space, you have a bunch of galaxies in a cluster, and you have another cluster behind them. The light will be bent by those galaxies. And the rate at which the light is bent suggests there's 10 times more mass in those galaxies than what we see. So there's two independent lines of evidence that indicate dark matter. So I think it's pretty good.
Yeah.
But check out Danny Faulkner's stuff.
Yeah. Oh, I'm so glad you mentioned him. I've enjoyed some of the talks I've heard from Dr. Faulkner. It's been very good. Well, and I think that gets into one of the topics I'm really excited to hear from you on is the Big Bang, because I've heard appeals to dark matter from secular scientists, but particularly I want to look at, well, let's start with, does the Big Bang and the Bible fit together? We'll start with the Bible's teaching and then look at the science on that after that.
Good. Yeah. And that's a good question to ask, because I think a lot of Christians who haven't studied it think, well, the scientists say this is how the universe came into existence. It must be the way God created. No, it's not. The Big Bang is not compatible. Well, maybe I should start by talking a little bit about what the Big Bang is, how it's supposed to have unfolded. The Big Bang is the idea that the universe popped into existence from nothing, from a quantum fluctuation, from another universe, whatever, by whatever mechanism. It popped into existence about 13.8 billion years ago. So the time scale is very different from biblical creation. And when it pops into existence, it's very small. It's smaller than an atom, but immediately expands out very, very rapidly. And as it does so, it carries all the energy. So the universe, all the energy that would eventually become everything else, is packed into this little atom, basically, this little primeval atom. And so it expands out. It's too hot for matter because the temperature is outrageous. It's more than you can comprehend, really. It's hard to put a number to it. But it's so hot you can't have ordinary atoms and things like that. They would be ripped apart by the energy. So it's just energy, a lot of photons, things like that. As it expands, it cools, and some of that energy becomes matter, things like atoms, protons, neutrons, eventually collecting into atoms and so on. Some of those atoms collect into, gravitationally, they collapse into stars. The stars then fuse the heavier elements, and they explode and release the heavier elements in the universe, and then planets some planets form from that and other stars, and then eventually Earth's one of those planets that forms, and then the story takes over from there. You have life evolving on Earth and so on. And that's incompatible with the Bible in many ways. The time scale is incompatible. The Bible says God created in 6 days. It's clear from context those are ordinary, approximately 24-hour days, because each is bounded by an evening and a morning and so on.
Right.
And in days when it's light out, God defines it for us. So there's no doubt about that. Whereas the Big Bang requires 13.8 billion years. The exact number changes from year to year as they revise their estimates. But the order of events is different. The Big Bang has stars coming about billions of years before the Earth. The Bible has the Earth being made on day one. In the beginning, God created heaven and the Earth was without form and so on. And then stars are made on day 4. So
Right.
the order's different. So even if you tried to make the days long or something like that, that's not going to work. The order's very different. The mechanism's different. The Earth is, according to Scripture, it's made by God. It's made supernaturally on day 1. Stars are later. According to the Big Bang, the Earth is made of stardust. When stars explode and release their dust, some of that collects and forms the Earth. So the mechanism's different. The time scale, the mechanism, everything is different. And the motivation's different. The motivation for the Big Bang is to try and explain the origin of the universe naturally. That is, or naturalistically, maybe I should say. That is, it's trying to explain how the universe came into existence and how it came to be the way it is today without invoking God. And so that ought to give Christians pause to say, wait a minute, we shouldn't even be thinking along those lines because the universe was created. So it is theologically incompatible with the Bible.
Yeah, absolutely. Yeah, thanks so much for breaking that down. So there's one point I hear brought up, and there's a lot of discussions with atheists, but also amongst believers as well, is, well, this doesn't seem coherent because the light issue of when was sunlight, and because you have, I think the sun was on day 4, correct?
Mm-hmm. Yep.
But then you have 4 literal days before that, and so the question is always, how could you have a day without light before the sun?
Yeah, it's not a problem. It's strange that people think, how can you have light without the sun? Well, I have light in here. I don't have the sun in here.
Right, exactly.
You can have light without the sun. The sun is a source of light. It's not the only
Right.
source. God provided a temporary source of light for those first 3 days. And then some people have the impression, well, wouldn't that affect the length of the day? Right? Because apparently, I don't know, maybe they think the sun goes around the earth and that causes the length of the 24 hours. No. It's the rotation of the earth that causes the length of the day. The sun has very little to do with it. As long as you have a light source and a rotating planet, you're going to have ordinary day and night. Did we have a light source for the first 3 days? Genesis 1:5 or Genesis 1:3, and God said, let there be light, and there was light. So yeah, we had a light source. Did we have a rotating planet? Well, again, Genesis 1:5, and there was evening and there was morning, day 1. So yeah, we had a rotating planet. So you're going to have ordinary day and night for those first 3 days. It's just that God used a temporary light source instead of the sun for those first 3 days to illuminate half of the earth, half of the surface of the earth. So it's not a problem.
Right. I've heard some debate on what the source was. Like some people appeal to Revelation to say, well, God's going to be the source and there won't be a sun, right? I don't know if you had any other thoughts related to that.
I avoid speculating on that because the Bible doesn't tell us.
Yeah,
It happened in the past, so it's not something accessible to science. So I don't think it's God himself. I think it's a temporary light source that he created because he divided the light then. He's not dividing himself.
Yeah, that's a good point.
Yeah, so it's some temporary light source that we don't have access to today. It's gone. And I think probably the reason God did it that way is so that people would be less inclined to worship the sun as the ultimate source of life, which most ancient cultures did. They worshiped the sun. The Egyptians, they had the sun god Ra and so on. And even the Hebrews, a lot of times they fell into that as well sometimes. But it makes it less tempting for God to just displace it a few days to show the sun's not primary. God's saying, I'm the primary source of life. The sun is just something I made. And he doesn't even call it by name in Genesis. It's just the greater light that rules the day. The lesser light, the moon, the lesser light to rule the night. He doesn't even name them. You name something, it might be a deity. And God's saying, no, these are objects that I created to sustain life that I made in the beginning.
I'm so glad you brought that up because there is no one like God, and there's no comparison. And just that point alone, that God everything he does has a perfect reason, and we should never assume that he doesn't have a good reason, even if we don't understand it.
That's
Um,
exactly right. Yeah.
and
And since God's mind is infinite, there will be an infinite number of reasons for things that we'll never know. And that's why God gave us faith to trust in him. He's a good God. We should trust in him.
Amen. And I think that's so awesome thinking about. Well, he is showing all of these false deities are not the true deity, and through just the order of creation. It's a strong apologetic of the days of creation, and of course our regular work week as well. I'm glad it was not 6 million years, because that would be a long time before we had a Sabbath.
It would.
So so yeah, let's get into the scientific issues of the Big Bang, which I think there are many. And I really hope our listeners will continue listening here, because um, everyone acts like it's settled science. And it's kind of surprising when you start looking at it. Even many apologists, friends of mine, just act like this evidence is so good. But I think we need to take a second look. So let's first, again, starting from the scientific method, does the Big Bang meet that standard?
It's I guess you could call it a scientific model in this just
Okay.
because anything counts as a scientific anything that um, tries to explain some aspect of the universe and make some kind of prediction as to what's going to happen in the future, or a future experiment, qualifies as a scientific model. Okay, but it's not a very good one, because a good scientific model makes testable, specific predictions about the outcomes of future observations or experiments. Specific predictions. And they can't just be vague. They can't be, if I say, well, sometime tomorrow something will happen. That's my model. Tomorrow something will happen. And something, lo and behold, something happens tomorrow. And you say, see, that's proof of my model. No, it's not. That wasn't a specific prediction. If I could predict when lightning would strike, that would be a little better. If I could say lightning will strike this spot right here at 12:47 and 23 seconds, and if it worked, you'd be like, well, you're onto something there, Lisle. It's a good model. The Big Bang really hasn't made any specific successful predictions. The only prediction I can really think of that you might count would be the discovery of the cosmic microwave background, and that requires some explanation. If you could see microwaves, and you go outside at night, you'd find the sky would be sort of a glow with faint microwaves coming from all directions in space. And that was discovered in 1964. And in a sense, the Big Bang sort of predicted that. I'll grant that. And those microwaves have a temperature associated with them of about 2.7 degrees above absolute zero, so they're quite chilly. Space is very chilly. And it's been argued, well, the Big Bang predicted about 3 degrees above absolute zero would be the temperature of space. And some predictions, it's true that some predictions did make that. Some predictions predicted lower. Some predictions went up to 50 kelvins above absolute zero. So there's actually quite a wide range of predictions, and one of them happened to be not too far off. So there you go. So there's your one successful prediction of the Big Bang, but it's not very successful because the Big Bang predicted that there ought to be large fluctuations in this cosmic microwave background, but in fact they're much smaller than the Big Bang predicted, factor of 10 to 100 depending on which predictions you look at. And those fluctuations are necessary to seed galaxies. So that's an issue. So you might say the Big Bang predicted the cosmic microwave background, but that's not a very robust prediction, because any universe that has an average temperature will eventually give off microwaves. And so it's a little bit like the prediction I mentioned earlier, where tomorrow something will happen.
Right.
Yeah, any universe will eventually have microwaves in it if it has any kind of energy, because that energy will eventually collect in dust. The dust will irradiate it. Eventually, you're going to get microwaves. So I think that's not a very good prediction. And also the other thing that makes a good scientific model is it's relatively simple. The simpler the model, the better it is. And that people who are not scientists, sometimes they get puzzled by that because they think of a scientific model as being very complex and lots of math and so on. The best models are the simplest. Newton's laws of motion and gravity can be written down on an index card.
Yeah.
And they explain the motion of everything in the universe as long as it's significantly less than the speed of light and so on. Einstein built on that. But that's good science. that's really good science. You can write them down on an index card, or Maxwell's equations, which describe all electromagnetic phenomenon. You can write 4 equations, you write them down on a card, there they are. It describes all electromagnetic radiation in the universe. That's a good model. The Big Bang is horribly complicated, and it does give an explanation, I would say a wrong explanation, for why the universe appears the way it is today. But it requires lots of fine tuning in order to adjust that without any kind of mind behind that fine tuning to do it. So it's not good science. It's not good science. It's a story about the past that secularists embrace because they have no alternative. The alternative would be creation, and they are unwilling to accept that.
Right. Yeah, absolutely. And thanks for breaking that down for us, especially the cosmic microwave background. That really helps, because I think a lot of people are thinking that, well, the biblical creation model, how do you explain that? But as you're saying, it doesn't seem like that's really a problem. And
Yeah, there are lots of different ways you can get microwaves, and I mean you have an oven that does it. So I mean
yeah.
Microwaves are what you get when something radiates, and it's about 3 degrees above absolute zero on average. You're going to get microwaves radiating from it. So I'm not sure that requires much of an explanation. Now, in terms of the details of what in space is exactly giving off those microwaves, I don't think we know for sure. But again, it's not a very robust prediction. The universe will eventually have an average temperature and will give off microwaves. So that could be just what we're seeing right there.
So is it an assumption then to say that's the afterglow of the Big Bang? Because that's
Absolutely.
what they're assuming. They're saying microwaves are the afterglow.
Yeah. There's no evidentiary basis for thinking that. There's no reason in the evidence why you would have to assume that that's the cause, that the Big Bang is the cause of those microwaves. Lots of things could be the cause of that. And interestingly enough, there's some evidence, and I haven't used this too much because I want to investigate a little bit further to make sure it's really solid. But there's some evidence that the cosmic microwave background isn't really a background, but it's a foreground, that it's much closer than people think, because there's an effect when microwaves travel through galaxies. Some of them get deflected. There's an effect where basically you should see a shadow in the cosmic microwave places where galaxies are. You should see shadows there where the microwaves have been blocked. It's called the Sonya-Zeldovich effect. And we don't see that, or at least we don't see nearly enough of it. And to me, the most reasonable explanation of that would be the microwaves their source is actually closer than some of those galaxies. So it might be something that permeates space rather than something that exists only at an extreme distance. And that evidence, I think, is very contrary to the Big Bang's explanation of the cosmic microwave background. I'll grant I don't know the detailed cause of it, but there's good evidence it's not the Big Bang.
Yeah, and some encouragement definitely for people to dive into that. That sounds interesting to explore. Now, another reason that people think that the Big Bang happened is, of course, they say the universe is expanding. And I hear that's one of course, the others is the weak radiation, the cosmic background we talked about, and distant galaxies seem to be rushing away from us. So what are your thoughts on that then?
The universe does seem to be expanding in the sense that if you're located on any one galaxy, all the other galaxies seem to be moving away from you. It doesn't matter where you're at. Could be so it's as if everything's just being stretched out and expanded, like raisins in bread. As you bake the bread and it expands, and the raisins all move away from each other. If you want to be a little more precise than that, think of ants or worms moving through the bread. If they're real close to each other, they might be able to overcome the expansion and actually meet. And so there are some galaxies that are very close to ours that are actually moving a little bit toward us, like the Andromeda Galaxy, M31. Because it's so close, its motion through space is greater than the expansion of space between our galaxy and that galaxy. And those are called peculiar velocities. It has nothing to do with being peculiar. It's just, there's Hubble flow, which is the overall expansion of the universe, and then peculiar velocities, which are the motions of galaxies in space. And we only see the combined effect in the redshifts of these light. But so aside from the very few nearby galaxies that are moving toward us, the rest of them are moving away, and the farther away they are, the faster they're moving away, the greater their redshift. And that would make sense if the entire universe is being stretched out or expanded. I think it is. And I think the Bible actually mentions that. In passages like Isaiah 40:22, it says that God stretches out the heavens like a curtain, spreads them out like a tent to dwell in. And so, and there's many other passages as well in Scripture that teach that God somehow stretches out the heavens. He doesn't tell us why, he doesn't give us the reason, but apparently God made the universe with size and he stretched it out a bit since then. A lot of people think that this is somehow evidence for the Big Bang, but it really isn't, because I can imagine God creating a universe 6,000 years ago, and then he's stretched it out since then. That would explain the light we see from these galaxies. Perfectly reasonable within a 6,000 year explanation. Not a problem at all.
Right.
I think some laymen think that the Big Bang predicted this expansion. It did not. The expansion of the universe, the fact that galaxies are all moving away, or almost all of them are moving away from us and from each other, was discovered in the 1920s, the late 1920s. Edwin Hubble found the relationship between expansion and distance, or recession velocity and distance, of these galaxies. The Big Bang, the idea that the universe came from a point, was 1931. It was invented by George Lemaitre, and he already knew about the expansion of the universe. And so my point is, the Big Bang did not predict the expansion of the universe. It was a secular explanation for the expansion of the universe. Now, Lemaitre did believe in God, but he held to methodological naturalism. He believed that you should leave God out of the equation when you describe anything, including apparently the origin of the universe. And so he in 1931 came up with the idea that the universe started as a point and then rapidly expanded, and today we're just seeing what's left over. But there is no logical reason to assume that the universe began as a point, as opposed to beginning with size, and it's stretched out just a bit in the few thousand years since creation. So expansion does not support the Big Bang.
Right. Yeah, no, that helps a lot, because to me that always seemed very persuasive. And then I kind of looked more in depth at Scripture, and then I heard some of your videos explaining that. And I always thought it was a necessary requirement. If it's expanding, it must have been smaller. But as you explained it, that doesn't have to be the case. It's not a
It doesn't have to be smaller. It just doesn't have to be.
Yeah, absolutely.
Yeah.
Yeah, not as they're claiming. To me, there some of the other ones that I think are really significant it's what's called the antimatter problem. Maybe you can explain that.
Yeah, the antimatter or the baryon number problem. Got a couple different names, but yeah, remember the story that I told earlier. The Big Bang story is the idea that the universe, when it's very small, it's just pure energy. You can't have atoms with temperatures that high because they get ripped apart. The energy's too intense. And so as the universe expands and cools, some of that energy becomes matter. Now, atoms, protons, neutrons, electrons, and they form atoms and so on. And we know that energy under certain circumstances can become matter, because we can do it. We can create matter in high energy collisions where we take particles, slam them together, and from that energy you can get new particles, and including protons and neutrons. You can the constituent parts of atoms. So we know that can happen. But our experiments also show that every time you take energy and convert it into matter, you get an equal amount of antimatter. And antimatter is the same as matter, but the charges of the particles are reversed. So, if you have an atom which has protons in the core and it's got electrons circling around, you can have an anti-atom. An anti-atom would have antiprotons. They're negatively charged versions of protons, and anti-electrons called positrons, which are positively charged electrons circling around it. And so if the universe really did come, if all the matter in the universe really did come from this energy in the Big Bang, there should be an exactly equal amount of antimatter everywhere in the universe.
Yeah.
All our scientific observations have demonstrated that whenever energy is converted to matter, you always get an equal amount of antimatter. There are no known exceptions to this. And therefore, if the matter in our universe came from energy, there must be an equal amount of antimatter, and it's not there. It's not there. The only place we find antimatter in the universe is where it's produced locally and almost immediately disintegrated when it comes into contact with ordinary matter anyway. Because when matter and antimatter touch, they blow each other up. They release energy. They go back to energy. So the fact that our universe is matter only is very perplexing to the secular scientists. It's a feature of creation, because we would expect that, because if God had made the universe equal parts of matter and antimatter, any place they touch, they explode, they blow each other up. So it would
Wow.
be a dangerous universe to live in. God made the universe essentially matter only, with only trace amounts of antimatter that are, again, produced locally. It's a design feature, but it's very hard to explain, this baryon asymmetry problem. And the best that secularists can do is to propose that once in a while, when energy makes matter, there's no antimatter, it just makes matter. But that's pure speculation. That's never been observed in any experiment, and so it's not something that's supportable scientifically.
Yeah. Wow. And that sounds like a just so story.
Yeah, it
Once in
is.
a while. That's a trigger word right there.
Yeah,
And to me, that when I heard that explained as you did so well, is that people need to understand this. This is not a this doesn't match its predictions, and it has a lot of rescuing devices of just so explanations. You hit it earlier, was kind of related to the temperatures and the universe, and I think this is connected with the horizon problem. Maybe you can explain that one.
yeah. So it's interesting because it's a light travel time problem, and
Mm,
the secularists like to think that creationists have a light travel time problem. How do you get light from those distant galaxies to the Earth within the biblical time scale? Now we have an answer to that, and I think it's a pretty good one. But the ironic thing is the secularists have the same type of issue, and I don't think theirs is resolvable. It's called the horizon problem, and the idea is when the universe is very small, the size of actually smaller than a grapefruit. It's there. You'll have some places that are hotter. It's extremely hot, but you'll have some places that are hotter than others, hot spots. Okay, and that's due to the Heisenberg uncertainty principle. It would have to be the case that some places will be hotter than others, just
mm,
randomly. As the universe expands, those places get pushed far apart. Today, we notice that the universe has almost the same temperature everywhere. Now, it does have small fluctuations in it, but the kinds of enormous differences that were expected, we don't see them. We don't see them. And so somehow, the universe has come to the distant universe in terms of the cosmic microwave background has somehow come to the same temperature or almost the same temperature to within a very small fraction. But how does that happen? In order for a hot spot to dump energy to the cold spot, it's got to dump it via light, or it could be something else, but everything else is slower than light. So light's the fastest way to do it. It could give light from this object from A to B, and then A would cool off and B would warm up, and you could even out the temperatures. But the funny thing is, even if you give them 13.8 billion years, there's not been enough time for light to travel from A to B even once,
mm.
even out those temperatures, let alone the multiple times it would take to really bring them to equilibrium. And so it's a light travel time problem. And it's one that the Big Bang folks have, which I think is very interesting. So they can't really, in good conscience, chide us for having a light travel time problem when they have the same type of issue. It's not really resolved. Some people think that if you've heard of inflationary Big Bang models,
Yeah,
that's an attempt to solve the horizon problem. But basically, a lot of times people think, well, maybe you can make the universe even older. That'll settle the problem. It doesn't.
it makes it
Because
worse, right?
yeah, no matter how big you make the universe, the light from one side of the visible universe is just now reaching us. So obviously, it's going to take much longer to get over there, and yet these two places have the same temperature. How does that happen? And so my secular colleagues have proposed inflation. They say that when the universe is very, very small, it suddenly, the temperatures even out kind of then, and then it suddenly expands at a much, much faster rate, and then goes back to the slower rate. And this fast rate is the inflation. And what caused it? Well, some kind of symmetry breaking. Nobody really knows for sure. What caused it to stop? No, well, who knows? And how do you get it to stop everywhere at the same time? That's an issue. So inflation has its problems as well. And not all secular cosmologists believe in inflation because they know
Mm.
it has problems. And so they think that the solution lies elsewhere. But that's the horizon problem. And the thing about
Wow.
these problems with the Big Bang, I take these from the textbooks. I haven't, these are, I mean, it'd be perfectly fine for me to analyze and come up with issues myself, but I think this is neat because these are things you can look up in a secular textbook. If they're honest, they'll admit that these are problems with the Big Bang. Perhaps they think they've resolved some or all of them, but they are there. And so you can encourage people to read up on those and learn about the horizon problem, the monopole problem, the flatness problem, the baryon asymmetry problem, and so on.
Yeah, wow, that's awesome. I think that really helps me and hopefully our viewers as well. Um, I think it it's so amazing. I'm so glad you brought up the inflation because again, that's another rescuing device. And I can tell you almost every week when I, log into my phone, I'll see another we've solved the Big Bang mystery. But I kind of think if you've solved it again, you never had it figured out to begin with. Is the funny thing, even without reading the article. And it's always involving some form of inflation that has some unknown cause.
Yeah,
So,
and the fact that they keep proposing new ones too suggests that the old ones really weren't satisfactory. So you can expect to
yeah,
continue to read those kinds of articles.
yeah, it's a very interesting. I'd recommend people to read your articles on your website, Biblical Science Institute, correct.com.
Yeah, yeah. In fact, we have a couple on the Big Bang, some of the topics that we've
Oh, good,
discussed here. Yeah, so they're on that website,
awesome,
biblicalscienceinstitute.com.
awesome. Well, I want to get in as we kind of talking a little more related to the Big Bang, but also, as you said, it overlaps with the light travel problem as well. But I've heard you mention, and several other scientists mention, the mature galaxies and cosmological principle. So that has implications on the light travel problem and also the age of the universe as well. So maybe we can talk about mature galaxies. What is because a lot of scientists are saying when we look at the stars at night, we're seeing stars from billions of years ago, but would you think that's actually the case, though?
I don't. The Bible indicates that God created the entire universe thousands of years ago, and there's a couple different issues there we can discuss. There's the prediction of the secularists that distant galaxies should just be starting to. You should see galaxies in the process of formation, and that's not what we see in the distant universe. We've taken the Hubble Space Telescope, pointed out there's the Hubble Deep Field, there's the Hubble Ultra Deep Field, about as far out as we can look into space. And you'll find fully designed galaxies there. Spiral galaxies, looks like they're even wrapped, similar to ones nearby. And some will say, well, there are systematic differences. And I'll grant there are some differences, but that's okay. It doesn't. The fact is, these galaxies are not in the process of formation. They're fully designed already
Mm.
at distances that were really surprising. The Hubble Deep Field was shocking to secularists to see these fully designed galaxies at distances where they thought they should just be starting to form. They're not just starting to form. They're there. And they're fully designed.
Wow.
They're mature galaxies at these tremendous distances. So that's a problem for the secular view. With regard to how you get the light from there to here, that's an issue. It's actually easy. It's hard. I found it hard to give a soundbite answer to
Yeah.
that because it requires knowing something about physics. But first of all, it's not an issue with any star you see in the night sky. All the stars you see in the night sky are within a few hundred light years. Well, Deneb's 1,600 light years away. That's one of the most distant ones you can see naked eye. So they're all well within the 6,000 light year radius that people think we should be able to see. But it turns out that the time it takes for light to get from, say, a distant galaxy to the Earth, so a galaxy you could see in your telescope, for example, that time it's not an objective absolute quantity that's the same for everybody. It's relative. And it turns out that time is relative to two things. One, it's relative to the reference frame of the observer,
Mm.
his motion and or position depending on various circumstances. And secondly, it's dependent on what's called a synchrony convention, which is how we choose to define what now means in distant space. What now means here is obvious. I look at my watch. That's now. Now's the time, according to my watch, that I make the statement. But what about distant space? How do you define what constitutes now? There's more than one way to do it. And Einstein was well aware of this. He wrote about it. This principle is called the conventionality thesis, or the relativity of distant simultaneity. And the fact that what constitutes synchronized clocks in one frame does not in another. The bottom line is the time it takes for light to get from the galaxy to the Earth depends on those two things. It depends on the reference frame of the individual and the synchrony convention. From light's point of view, the trip's instantaneous. From light's point of view, every trip is instantaneous because light doesn't experience time. And so you think, oh, that's interesting. So it takes no time at all from the light's point of view. That's interesting. But it turns out you can even do it from our point of view. It's called an anisotropic synchrony convention, which is something that Einstein toyed with, although he ended up preferring a different convention because it makes the math easier. The alternate synchrony convention basically defines now such that light takes no time at all to get from there to here. And now a return trip would take time, but the light doesn't have to return, it just has to get here. And I think the Bible uses this anisotropic synchrony convention when it describes celestial events because all ancient cultures did. No ancient culture used the modern, what's called the Einstein convention or the isotropic synchrony convention. They didn't subtract off light travel time. When you see something happen, that's when it happens. And I think the Bible is using that language. And that it surprises people because they think, well, the one way, the speed of light in one direction should be measurable. It's not unless you make certain assumptions that presuppose the one-way speed of light, ironically. And so it's not something that can be objectively measured without first assuming it. Again, this is called the conventionality thesis. It's been discussed in physics literature for the last century. It's well known among people who are familiar with this topic. It's just most people aren't familiar with the topic. So
Right.
I actually wrote a book, The Physics of Einstein, that will bring people. There it is. That's it. Yes,
Right
The
here.
Physics of Einstein.
Good. Yeah.
And the idea is to give people enough knowledge of the physics of Einstein so that in the last chapters there, in the last few chapters, when I talk about synchrony conventions, it'll make sense to them, and they'll see, oh yeah, starlight's not a problem for biblical creation. God really did create in 6 days. He made the stars on day 4, and their light arrived immediately. It didn't take any time for the light to arrive on the earth.
Right. Yeah, that's awesome. Thanks for breaking that down. And even as we discussed before, even without that, you have the horizon problem that shows that secularists have a light travel problem on their own end. And so I think they can't just shift the burden of proof there. They have the burden of proof, absolutely, on this issue to make what best explains it in their model. I think the biblical explanation makes the most sense. And then you hit on too that I think in Genesis, God, it's described that the light was intended to immediately, excuse me, the light was intended to immediately be visible.
I think it's implied, yeah, because it says, and it was so. And
Right.
of the thing you mentioned is the creation of the lights to give light upon the earth, and it was so. I think that indicates they immediately gave light upon the earth on that day. So it didn't take any time at all. And that would make sense if the Bible's using this anisotropic synchrony convention. That would make perfect sense.
Yeah, it fits so well. Now I heard a lot of seculars say the cosmological principle is essentially saying that there's no unique place in Earth, right? But there's probably a better way to put it. And there's no special directions or when I thought this through recently, I realized it's actually very significant towards understanding. I think it's a moment of worship if you understand how there are unique places in the universe, if I'm understanding it right. Because the cosmological principle, would it say that everything would be evenly divided out and there's no unique spots? No clusters, right?
It would say basically every location in the universe looks about the same.
Okay, that's what they were assuming would happen, right?
We don't actually know that. We know it works well nearby, but we don't know that that's the case for a distant galaxy. It could be, but it doesn't have to be. It doesn't have to be.
So say like a cluster of quasars. Is that a problem in a secular worldview? Because wouldn't you not expect clusters, though? That everything.
It's not a violation of the cosmological principle, because they would say on the largest scale, things anywhere in the universe look about the same as everywhere else. There are local concentrations of mass. That's understood, but that's not a violation of the cosmological principle. So the cosmological principle basically is that the Earth is not in a necessarily preferred position. And that's certainly true with respect to our solar system, because our Earth orbits the sun. You might say, well, maybe the sun's in a special position. Well, it's kind of at the outskirts of the galaxy, and maybe our galaxy's in a special position. And it could be, but every time we've assumed that we've been wrong. So the cosmological principle may or may not be right. They used to hold to what's called the perfect cosmological principle, which is that the universe is not only the same everywhere, but at all times. And nobody believes that anymore. At least nobody who holds to the Big Bang, because the universe was smaller in the past, and in their view, it was really small at one point. So it's interesting. The cosmological principle, which most astronomers hold to, I'm ambivalent. It could be true. I don't know. There's no data one way or the other. But the perfect cosmological principle we know is false, or at least everybody assumes that, because in the Christian worldview, the universe didn't exist at one point, so of course it's false. But even in the secular view, it's interesting. My point is those are philosophical frameworks. They have nothing to do with scientific observations. They are philosophical frameworks.
Right. No, that's helpful to understand. But there's one question we had from Anna Nelson. She said, my daughter, age 12, wants to know, how do you explain a black hole from a biblical worldview? She loves science, completing 3 years worth of science per school year. She just finished Answers in Genesis Astronomy, but wanted more explanation in regards to black holes. Thank you in advance.
Cool. Well, one thing she should check out, I have an article that I wrote for the Answers in Genesis website. It's actually on their website on black holes. You might look at that first. But basically, a black hole is a region in space where the gravity is so intense that light can't escape. You can think of space. We talked earlier, space is not nothing, it's something. And it turns out space has a kind of motion. And one of the things Einstein discovered is that gravity is not a force that pulls on mass. You can think of it as a force that pulls on space, and mass just kind of goes along for the ride. You can think of it like a river, you know, and or a lake. Where there's no gravity, it's like a lake. And then you pull the cork on the bottom of the lake, and the water starts to funnel in like that. That's what a black hole is, except that the surface of the lake represents space. So space is kind of falling in, and there's an infinite amount of space. It's infinitely stretchy, so it can do that forever. But if mass comes nearby, it will tend to go into the black hole. If you're close enough. If you're far away, you can orbit around a black hole. It's not a problem. But the thing that makes black holes weird is that light, they have a radius at which light can't escape. They actually have a radius at which light will orbit, amazingly. And that's
Wow.
one and a half times what's called the Schwarzschild radius. The Schwarzschild radius is the point of no return, because anything light inside that can't get out. It's like salmon trying to swim upstream but losing. Water pulls them back. Okay,
Yeah.
and so light can't escape. And since light's the fastest thing, nothing else can escape either. Once you're inside that event horizon or Schwarzschild radius, at 1.5 Schwarzschild radius, there you can potentially escape still. But that's the distance at which light will orbit, which I think's just cool to think about that. So if you're near a black hole, you might actually look out and see yourself in several locations, because the light from you has gone out and come back into your own eyes.
Whoa,
So
that's amazing.
it's
Wow.
really weird. Black holes are neat. They're really neat, and God might have had a couple. You know, people ask, why did God make them? There might be a couple reasons. We think that basically just about every galaxy has a giant, massive black hole in the center, and that acts as an anchor for stars. It's a gravitational source that keeps the stars in their orbits near the core of the galaxy. And also, they're a test of physics. Einstein predicted that these things would be possible. And so when we observe the effects of black holes, that tells us that we're on the right track in terms of understanding how God upholds his creation. So they're neat. They're neat to think about. They're really neat.
That is really cool. Now, what's the secular explanation for a black hole?
In the secular worldview, they are thought to be there's sort of two categories of black holes with a possible third. There's these giant galactic mass black holes in the center of galaxies, which I just mentioned.
Mm-hmm.
I don't think there's a good secular explanation at all for those. At least I've never heard one. They're there. They're kind of there. And then there's what we call stellar mass black holes, and they have the mass of a few times the mass of the sun. And we find those throughout the galaxy. There's none nearby, nothing to worry about. But secularists believe that those are the collapsed, where a star has exploded and the inner portions of the star have been compressed in and formed a black hole. And I think that's actually feasible. I think that some stellar mass black holes, maybe not all of them, but I think some stellar mass black holes could indeed be the results of a star that's exploded and pushed the implosion pushes the inner portions of the star inside its own Schwarzschild radius, and then it has to collapse and form a black hole.
Wow. Huh. Yeah. So speaking of stars, I hear a lot of people assume that stars could have formed given enough time. Time seems to always be the answer. But have we actually ever observed a star forming is I guess the key issue.
Nope, no one's ever observed a star forming. And you will see, you'll see it in the newspaper. Here's a star forming region. Let me clue you in. What they're seeing there are stars that are hot blue, and hot blue stars can't last billions of years. That's universally acknowledged, because they're the most luminous type of star. They expend their energy at an enormous rate, even though they have a lot of energy available. They use it up quickly. The candle that burns twice as bright lasts half as long, and so these blue stars can't last billions of years. And so yet we see them everywhere in the universe, and I think that's an evidence of a young universe. Right. My secular colleagues say, well, obviously these stars formed very recently, so this must be a star-forming region. That's where that idea comes from. It's not because they see any stars in the process of formation. That's never been observed, which I think is astonishing. And I mean, stars explode. We see that happen. I've seen supernovae myself.
Yeah.
And you think, well, you have to have a process to replace them if the universe is billions of years old, but we don't see it. And
Yeah.
there are theoretical problems getting a star to collapse too. And by the way, I'm not saying that I'm absolutely 100% convinced that star formation cannot happen. That's not what I'm saying. But I
Hmm.
am pointing out it has not been observed, and there are theoretical difficulties with it. I'll grant that a star is not an organism with complex parts working together. A star is a ball of gas, and there might be circumstances where gas could clump in on itself. But the problem is it doesn't normally happen because gas normally expands.
Yeah.
Any gas that has any kind of temperature, the temperature creates a pressure, and the pressure pushes out on it. And normally, anywhere we look in the universe, when we take a look, now gravity would tend to pull a star in, but normally, everywhere we look in the universe, the outward force of gas pressure is much greater than the meager inward pull of gravity until you get the actual star. Now, once you get a star, it's so compact, its gravity is intense enough to overcome the gas pressure, and it maintains a balance. But getting it to that state, very difficult. So there's gas pressure to overcome. There's angular momentum to overcome.
Mm.
Gas clouds have a little bit of rotation to them, and if you spin that in, it'll tend to do that. And then the centripetal force needed to overcome that is enormous, and so normally it can't go any further than that. And then there's magnetic fields. So basically, there are three things that would tend to prevent a star from ever forming: the gas pressure, the angular momentum, and magnetic fields. You try to push magnets together, they don't want to do it. And stars are the same way. So I'm very skeptical that stars can form, and certainly we've not seen it happen.
Yeah. Well, no, I appreciate your just breaking that down and really going back to what have we observed and what are the problems. It's really helpful. So let's get to the big issue here is that a lot of people I talk to, they will just scoff at a younger universe and they say the evidence is so overwhelming. How could you even suggest otherwise? But let's even look at how are scientists even coming to a conclusion of a 13.8 billion year old universe? Like, how do they even come to that number in the first place?
Well, that particular number comes from extrapolating the expansion rate under the assumption that it's always been the same, kind of the same. They allow for gradual changes in what's called the Hubble constant, but not any kind of supernatural change or anything like that. Nothing catastrophic. And the assumption of naturalism, the assumption that the universe was not supernaturally created at a finite time in the past. And you combine those two assumptions, and I know the second one's false. The first one may or may not be false, we don't know. But the second one is false. The universe was supernaturally created. So they assume two things, one of which we know is wrong. And then they assume, pushing that equation backwards, they say, well, at some point it must have been a point, and you can't go back further than that, so that's the beginning. And that's where they come up with the 13.8 billion years. It's by measuring the current expansion rate, taking into consideration the gradual change of that rate due to the different distribution, the more concentration of mass and that. So it does change a little bit, but gradually. And that's where they get the 13.8 billion years. So that's where that comes. So it's assumption based. It's not based on just the evidence. It's based on the assumption of naturalism, uniformitarianism, and applying that then to the current expansion rate.
Yeah, when it comes full circle to our beginning point of your starting presupposition is going to be very key moving forward and how you build your worldview. So let's get to, we've already mentioned that that's an assumption, but here's the issue of one thing I've been looking at recently, and it was actually in the other book I have of yours is Taking Back Astronomy. And I encourage all our listeners and viewers to get this book. It's a really good starting point too, because it's not as technical as some others, which I think I'm ready for the more technical. Well, excited to. I'm still learning, going through it slower. But this has really good pictures and diagrams on it. And when you started breaking down the magnetic field decay of planets and that problem, I was just blown away because I'm like, everybody needs to know this. This is so cool. And this is a problem though for an older universe. Can you explain why?
Yeah, so magnetic fields are caused by electrical current in one form or another. So perhaps some people watching this have even done this, where they've taken a coil of wire like that and touched the two ends of the battery, and you make a little magnet. You can pick up nails with it and stuff. It's pretty neat. So a current loop will create a magnetic field. The magnetic field is orthogonal to the current loop and so on. So basically there's current inside the Earth. That's why we have a north and south magnetic pole. And if you think about it, batteries, they run down over time. That current decays. It encounters electrical resistance. The Earth's interior is not a superconductor. It's not resistantless. It has resistance. And so the magnetic field decays with time. And we've been able to measure that for the Earth for the last almost 2 centuries. We know it's decaying. We know the total energy is dropping. And there are other effects too in terms of the pole directions can change a little bit with time and so on. But the fact that it's decaying, and we'd expect that from first principles of physics, tells us that it can't be billions of years old. As far as we can tell, it's an exponential decay. You run that back in terms of the energy loss. The strength is more complicated, but the energy loss is exponential. You run it backwards. I ran it back to 60,000 years in a hypothetical past and found that the Earth's magnetic field at that time would have been stronger than that of a neutron star, which is enough to rip the atoms of your body apart. So we're not talking millions of years. We're talking 60,000 years. It can't even be that old.
Yeah.
Now, 6,000 years, not a problem. 6,000 years based on the current decay, and I'm assuming a simple decay model. It's probably more complicated than that. But nonetheless, it would have been 20 times stronger at creation. That's nice. You get increased protection from cosmic rays. You see, our magnetic field acts like an invisible shield, and it deflects cosmic rays, which are harmful to the human body. They cause mutations and the like, cause disease. So not a problem in the biblical time scale. But it's not just the Earth. There's several other planets. Mercury has a noticeable magnetic field. It's not as strong as the Earth's, but that's because Mercury is a smaller planet, and it's decayed more quickly. But Mercury's magnetic field, and there's even evidence that it's dropped since the two spacecraft. There was a spacecraft that visited in the 70s, the Mariner 10 spacecraft, and then they sent Messenger a decade or so ago, and there's apparently a noticeable drop in the magnetic field, exactly what we'd expect as biblical creationists. Jupiter's got a magnetic field that would be bigger than the sun if you could see it. It's enormous, very powerful. It's actually too powerful for life even today. You get close to Jupiter, it induces currents in your body. That's not good. But anyway, we now have a spacecraft orbiting Jupiter, the Juno spacecraft, and they had to design it special so that it could withstand that magnetic field. That would not make sense if Jupiter were billions of years old. That magnetic field would be gone. Well, and I think it's interesting. My colleague, Dr. Russ Humphreys, he's a PhD in physics. He's a biblical creationist like myself. He was able to predict the magnetic fields of Uranus and Neptune based on their biblical age of 6,000 years, and he was spot on. He made the prediction in 1984. Before those magnetic fields were measured by the Voyager 2 spacecraft, it flew past Uranus in 86, measured the magnetic field, it matched Humphreys' prediction. Flew past Neptune in 89, matched Humphreys' prediction. The secularists were way off because they were assuming billions of years for those planets, in which case the magnetic field would have had plenty of time to decay. So, magnetic fields are an indication of something that can't be anywhere near millions of years old because they would be gone. They decay too quickly.
Wow. Yeah, that's amazing. I think that's so huge, especially hearing about Dr. Humphreys' predictions. I don't know why we don't hear about that more still. I think that's just amazing. And obviously, well, I guess I do know why. There is people don't want to hear a starting position of the Bible because their hearts love the dark and they don't want to believe that God's word is true. Ultimately, you mentioned Jupiter, and it immediately came to mind. And I know this is true of other planets, but I remember reading, and I think it was in Taking Back Astronomy, where Jupiter releases twice the energy it receives from the sun. So that seems to be another evidence, right, that it can't be billions of years old.
Yeah, that's right. Because if you think about it, if it's giving off twice as much as it's taking in, it's constantly losing energy.
Right.
It's only got so much. It's a big planet. It's 10 times the diameter of the Earth, and so 6,000 years, it's a drop in the bucket, the energy that it's lost. But if you move it to 4.5 billion years, the energy should be long gone, long gone. And it really is a significant problem in the secular worldview. Saturn does it too. Neptune does it even worse than Jupiter. Neptune gives off 2.6 times as much energy as it receives from the sun, and it's far away from the sun, so it doesn't have a source of new energy. It's true of a lot of planets. Earth gives off more energy than it receives from the sun, but with Earth, there's radioactive elements in it, and that's thought to be the source of new heat in the Earth's interior. And that's feasible. I don't know that it's the right answer, but it's at least feasible. But with Jupiter, it's made of the light stuff. You don't have the heavy elements in Jupiter or Saturn or Uranus and Neptune. and 3 out of those 4 have internal heat. And the last, I'll grant it's been a few years since I've read a secular publication trying to explain that, but they needed 4 different explanations for the 4 planets. So again, it's not good science. That's an indication you're dealing with rescuing devices rather than genuine
Yeah.
science. When you need 4 different explanations to explain four things.
Yeah. Yeah, that's never good. You mentioned Saturn. Well, one of the most obvious things that stands out is his rings. And my understanding is if the rings were billions of years old, they should be dark and they should not be as beautiful as they are. And isn't that, I mean, off of just predictions of what we see right today of asteroids that hit them, it wouldn't look like it should. It is right now.
Yeah, there is a darkening process that can happen
Right.
if cosmic radiation interacts. But I think even the more significant problem with Saturn is the rings will be gone
Okay.
because
Yeah.
they actually spiral inward because any collision causes both particles to lose energy, and so they have to drop into a lower orbit. And there are lots of forces that cause Saturn's rings. Saturn has a magnetic field. If you have any charges in the particles that are if any of the particles are non-neutral, they'll be affected by that magnetic field that'll slow them down. So there are several processes that cause Saturn's rings to gradually spiral in. And by the way, that's not disputed. Most secularists would agree that Saturn's rings are recent. And they would say, though, that they must have formed recently. And, okay, but here's the thing. All the 4 planets, the 4 big planets, all of them have rings. And so the idea, and they all must be, they all have to be recent. And so what are the odds that all the big planets of our solar system would have rings if that's just a transient phenomenon that happens for a short period of time every now and then? So it's a probability argument that I think is in favor of biblical creation. But yeah, rings are young. You see rings, they're not billions of years old.
Yeah. Yeah, absolutely. Aren't there certain planets or moons that are rotating the opposite direction of each other as well?
Yeah, the most perplexing example for the secularists is Triton. Triton orbits Neptune, and it orbits Neptune exactly backwards. So Neptune's spinning. If you look down on the top of Neptune, it would be over its north pole. It would be spinning counterclockwise, and Triton goes clockwise. So they go in opposite directions, and Triton also rotates backwards as well. So it keeps its same face pointed toward the planet. So that's a very perplexing mystery to the secularists. Why? Because if the solar system, in the secular view, the solar system is supposed to have formed from a collapsing nebula, which spins, and the planets, as they form, they inherit the angular momentum of the nebula. So they really ought to all be spinning the same way, in the same direction, have roughly the same period even. And we find that really isn't the case. Jupiter's well behaved in the secular worldview, but that's about it. The other planets are tilted significantly. Venus rotates exactly backwards, and then some of the moons orbit backwards. Triton's the only large moon that orbits backwards, but there are lots of small ones that orbit backwards. Some of those could be captured asteroids, that's fine. But I think Triton really puts a wrench in the secular formation scenario because it's a huge moon. And it's orbiting just exactly the opposite way that the secularists would expect.
Wow. Yeah, that to me, when I saw your presentation, it's Journey Through Space, and again, I want to do a shout out for any church leaders, or if you're not a leader at your church, but maybe you have a position to share. You guys need to bring Dr. Lisle out to your church and have him give that presentation. It's phenomenal. And when you talk to what you call like Easter eggs or little golden nuggets or in the universe, I love the way you put it because it's so true. You're like, I didn't know about that, and that's a little thing that we don't always talk about, but that fits so well in the biblical worldview. And I think we're missing out on a moment of worship when we don't see these details of God's design in the universe.
Oh yeah, I love it when God puts these little gems out there. And in fact,
exactly.
on our website at biblicalscienceinstitute.com, I've recently been going through the solar system. I've had articles on the solar system, and I've tried to include some of those little Easter eggs where God has done something something we wouldn't have expected, and it's just neat. And it's if you're a Christian, you can just enjoy that. You can say, "Wow, the mind of God is amazing to think of these things."
Amen. So I want to wrap up with 2 other things related to what we've been discussing is, so the rescuing device for magnetic fields, to me, that is one of the strongest arguments for a young universe. And of course, we've hit on many others. Is the dynamo theory, and you cover that some in taking back astronomy. Now, what is the dynamo theory? Does it actually explain away the problem? Because my understanding is it's kind of how could it trying to explain how magnetic fields could recharge themselves, right?
That's the idea, yeah.
Okay.
The idea is it's like a little bit like the alternator in your car, where it takes
Mm,
mechanical energy and converts it into electrical energy to restore the magnetic field.
yeah.
And okay, I mean, yeah, I mean, there's nothing magical about it. You can take mechanical energy and turn it into electrical energy. That's what your alternator does. But your alternator is kind of a sophisticated machine, and planets don't have sophisticated machines in them. So it's doubtful whether something like that could work in a planet. It requires a few things too. First of all, the dynamo theory proper requires that the rotation of the planet be kind of the source of the electrical current, and therefore the rotation axis and the magnetic axis should be the same or very
Mm,
close. And for the Earth, they're tilted. They're 11 degrees tilted. Not too bad. Not too bad. Jupiter, similar. Uranus, not even close. Not even close. The magnetic field of Uranus is totally whopper-jawed compared to the rotation of the planet. And likewise with Neptune. Neptune's tilted, but its magnetic field is not aligned with the rotation axis at all. So that really challenges the dynamo model. The dynamo model does suggest that magnetic fields might flip with time, and so when they encountered Uranus, they said, well, maybe it's in the process of flipping. But then they encountered the same thing at Neptune. They said that's really unlikely that you get two that are both in the process of flipping. Now, something like the sun does seem to have something like a dynamo going on it, where it converts mechanical energy into electrical, but and that causes the sun's magnetic field to flip every 11 years. But we've not seen that on any planet.
right.
We think that during the flood year and shortly afterwards, Earth's magnetic field did flip. We think there's evidence for that, but that's because there was motion. There was a lot of motion going on in the Earth's interior, and that can disrupt those currents. Today, we don't have that, and so we don't expect the Earth's magnetic field will flip again. It's settled down into kind of an exponential decay now. But even the magnetic field flipping that's going on in the sun, it's never been demonstrated that that actually recharges the magnetic field. It might actually drain it faster. So just because you have some kind of interaction between motion and magnetic field, which we do have on the sun, that doesn't necessarily mean that that is an adequate explanation for why magnetic fields are as strong as they are. I actually think it might make them drop quicker. Any kind of flipping like that might make them actually drop faster.
Has that been something you've looked into more, or some of your colleagues?
Yeah, Russ Humphreys has looked into it in detail. You might take a look at some of his articles, and he's even done technical papers refuting the dynamo idea,
Oh,
showing
wow.
that it leaks energy at certain points, and it's not a good way to maintain a magnetic field or recharge it over billions of years. And it's inconsistent with the observations that the Earth's magnetic field is in fact losing energy, and likewise for Mercury. The two planets where we've actually measured the magnetic field at different times, they're both dropping. And you wouldn't expect that if the magnetic dynamo model were correct. And you certainly wouldn't expect places like Uranus and Neptune where the magnetic field's not aligned with the rotation axis.
Isn't the decay rate of some of those planets, has it stayed steady, or has it gone faster?
Well, if it's just a free decay of electrical field, you have an electrical current, the electrical current's decaying, the magnetic field will decay. The natural expectation would be an exponential decay. So it's not linear. It's not dropping like that. It's dropping like that. So it slows with time. And so
right.
that's the assumption. There's no reason to think that's not the case. And in any case, secularists tend to hold to a uniformitarian view anyway. So that would tend to be their natural proclivity, would be to assume that the rate's been kind of the same as it is today in terms of the rate that it's dropping. So we'll assume that, at least for the sake of hypothesis, and you find that you still get an age that's much less than the biblical age. Maybe I should explain, too. A lot of times when biblical creationists like myself present an argument from science that the world, the solar system, the universe is much younger than secularists believe, we will temporarily assume, for the sake of hypothesis, the starting points of the secularist, his epistemology, his view that rates and conditions have generally been constant. And even given those assumptions, many times we'll have an answer that's much less than the billions of years. So that confuses some people, but that's that's the right way to argue. That's an example of a reductio ad absurdum, where you temporarily assume the position of your opponent and show that even then it leads to absurdity in many cases.
Right. And I appreciate you saying that, because it's been sad to me to see people, I think, misrepresent the logical consistency of many biblical creationists, saying, well, okay, well, they'll assume your worldview, assume that, and see if that works, and if it's consistent with what we see, what explains it best. So we'll narrow in at the end here on the Earth itself. You've hit on in your book the recession rate of the moon and the sun, and how it seems very unique in our solar system. Maybe you want to explain that some more, on just, it seems like the moon points to a younger universe, and it points to a special design by God as well.
Yeah, definitely. So the moon is receding. It's moving away from the Earth. That's due to tidal forces. That surprises people. You think, well, wouldn't gravity make it move closer? Well, it's not gravity per se. It's tidal effects. So the moon pulls on Earth's oceans, and because one ocean is closer to the moon, it makes a lump on that side. The gravity's a little stronger, and on the other side, the Earth gets pulled away from that ocean. So the Earth gets elongated in the direction of the moon. But then the Earth's rotating, and it's rotating faster than the moon's orbiting. So those tidal bulges get ahead of the moon, and they pull forward on it. And when you pull forward on something in orbit, it moves out. Kind of strange, but when the astronauts want to go into a higher orbit, they thrust forward. That gives them energy, and they go into a higher orbit that way. So the moon is constantly moving into a higher orbit. It's not a huge effect. It's an inch and a half a year. The moon slowly moving away from the Earth, an inch and a half a year. We can measure that. We left reflectors on the moon when the astronauts were on the surface. They left these reflection devices. We can bounce a laser off of it, and by timing the trip, we can get the distance to the moon really precisely. So the moon is moving away from the Earth. You run the movie backwards, and you have to do the math right, because when the moon's closer, the tidal bulges would be bigger, so the rate would be faster, and it'd be bigger. In fact, you have to use calculus to do it right. And I've done that in the book Taking Back Astronomy. I've shown you how you can do that if you want to verify that. But you find that the Earth and the moon would be in the same place at the same time, 1.45 billion years in a hypothetical past. And you say, that sounds like a lot, but the point is they can't be older than that, because you can't have less space than no space, right? I mean, they can't be that old. And yet in the secular view, they're supposed to be 4.5 billion years old. And so that's a problem. That's the lunar recession problem for an old Earth or an old Earth-Moon system. And usually the way they'll get around that is they'll say, well, for some reason, the tidal breaking constant is much greater now than it was in the past. And so but then they're breaking their own assumption of uniformitarianism when they say that. So that's the only reason they believe in the billions of years in the first place, is uniformitarianism. So they have to violate their own thinking in order to come up with that rescuing device. So the moon is a good evidence of a young universe. It is designed. It's designed for life. It's got some unusual properties. It orbits in the ecliptic, which is the same as the Earth's orbit around the sun. It's within 5 degrees of the ecliptic. That's unusual. All other large moons, except Triton, orbit around their planet's equator. Our moon's different. Our moon orbits in the ecliptic, which is tilted relative to the equator by 23.5 degrees, something like that. So our moon's unusual in that sense. It's unusually large compared to the size of the planet. In fact, Earth has the largest moon relative to the size of the planet since Pluto's been demoted. But because Pluto was the winner before that. But yeah, and that's interesting, because that means the tidal effects of the moon are large. So it induces pretty good tides on the Earth, and that's a design feature, because it keeps the Earth's currents, it keeps the ocean from stagnating, basically, and helps clean the shorelines and so on. So that's a design feature. And of course, the moon does other things. It provides light at night when it's out, but it goes through phases. So you have some nights where you don't have much of the moon and you can see the deeper stars, and you have other nights where the moon's out and you can read the newspaper or whatever. So it's a nice design, and that's how we get our months. It helps us keep track of time. So that's where the word month comes from. It's a month. It's the amount of time it takes the moon go through its phases. So so it is designed for life. Life on the Earth, not life on the moon, but it's unique. The moon really is unique.
Yeah, that's awesome. Well, I just want to thank you so much, Dr. Lisle, for your time. It's been a huge blessing for me, and I know, no doubt, for our viewers and listeners. And I really want to encourage everyone, go to biblicalscienceinstitute.com, read Dr. Lisle's articles, check out his books, DVDs, talk to your church leaders about getting them out to your church whenever you guys are able to start doing live events again. And I think you've been making some videos as well on YouTube
That's
of your
right.
own videos, right?
That's right.
So,
Yeah.
so a great resource. It's been an awesome conversation. I really love this, and I hope you guys will share this with as many people as possible. So thanks again, Dr. Lisle.
Pleasure.
Looking forward to seeing some more of your research and your more articles. So thanks again. You have a great day.
You too.